So this next lecture will be from chapter 3, dealing with polynomial equations. So for example, we have in terms of this one, 6x to the fifth minus 7x to the fourth plus 13x cubed minus 25x squared plus 12x minus 25. And we want to know in terms of what degree is this equation and the leading coefficient. So the degree of the equation is going to be the largest exponent that we see. And so that is going to be 5. So this is a fifth degree polynomial. The leading coefficient, and then it's going to be the number that's in front of this term, and so that number is 6. So we have in terms of our polynomial degree and the leading coefficient. Another example of that would be one if I have one that looks like this. Again, we have a term of polynomial. Again, we want to know in terms of the degree and the leading coefficient. So in terms of this one, we have that this is x to the 8th, but if I look over here, I have x to the 6th, y cubed. And so it ends up that my degree for this one is going to be 9. So when I have one like this, I add these two together, and the leading coefficient would be minus 7 if I rewrote that in descending order. So we have in terms of degree and coefficients. Okay. Well, in terms of polynomials and graphs of these, okay. So we had in terms of like what we saw last week, a linear graph. Well, that goes something like that. We can have in terms of a quadratic graph. And so a quadratic graph is one that looks something like this. And then the third common type we'll talk about here will be in terms of a cubic graph. And a cubic graph then looks something like that. Right? So three basic types: linear, quadratic, and cubic. Right? Now, given an equation, so given something like this, y equals 2x to the fourth, 7x cubed, minus 12x, plus 25. And I want to know what is the end behavior of this. So I want to know what happens when x is heading towards infinity, and I want to know when x is going towards negative infinity. What is this heading towards? Right? Now, first off, x is getting really, really large, right? So as x gets large, okay, so now you think about a really large number, these terms really have no impact. And so as x goes to infinity, my equation goes to infinity. And now when x goes to negative infinity, well, if you take negative number and you raise it to an even power, you end up with a positive number, and so this is also going to infinity, right? Okay. So we have that we go toward infinity both ways, okay? And again, you think about what happens in terms of x, and think about it in terms of large numbers, all right? So for example, let's say here that x is 10 to the 20th. Well, if x is 10 to the 20th, then 10 to the 20th raised to the fourth power is 10 to the 80th. And if you have this term, 10 to the 20th raised to the third power is 10 to the 60th. Yes, this number is large, but it really is nothing compared to this. And so these terms really go away as x goes to infinity or negative infinity. Right? So another example then of this, and that would be given something like this. Y equals 7x to the 7, 6x to the 4th, 25x squared, minus 7. And again, I want to know what is the end behavior. So again, as x gets very, very large, so as x goes to infinity, then all of these terms have no impact, and so my equation is going to positive infinity. As x goes to negative infinity, well again, now this power is odd, and so when you take a negative number raised to an odd power, you get a negative number. And so this is going to be negative infinity. So we can figure out what happens at the end of an equation, okay? When we head out towards infinity and negative infinity, right? Other types. So let's say we have in terms of y equals x plus 4 times x minus 2. And again, you multiply that out in terms of your FOIL method, you should be able to figure out that this will come out to be x squared plus 2x minus 8. Again, in terms of FOIL, x times x is x squared, 4 times x is 4x, minus 2 times x is a minus 2x, so that's why we got the positive 2x, and 4 times a minus 2 is a minus 8. Okay? So I want to be able to figure out what's going on in terms of this graph, in this equation. So let's first off add terms at the x-intercept. Well, at the x-intercept, this is where the graph cuts the x-axis. And at the x-intercept, you have the y is always 0. Okay? And so we would have then that 0 is going to equal x plus 4 times the x minus 2. Okay? And so this says that this times this will give you 0. And the only way that will be 0 will be if either x plus 4 equals 0 or the x minus 2 equals 0. And we can solve each one of these for x. So here I would add 4. I'm sorry, add 4, but we're going to subtract 4. So we'll subtract 4. On this side we would end up adding 2. And so we get x equals negative 4 and x equals 2. So we got in terms of the x-intercepts are going to be negative 4 and 2. Well, then we look in terms of the y-intercepts. Right? So at the y-intercepts, so this is where the graph cuts the y-axis. At the y-intercept, we have that x. We're always 0. And so we said that our equation, if I multiplied it out, would have been x squared plus 2x minus 8. And if x is 0, and so we know that x is equal to 0, then we know that y is going to be positive 8, or negative 8, sorry, negative 8. Right? So we have our x-intercepts, we have our y-intercepts. The next thing is what happens at other parts of this graph. Right? So we're going to make a little chart. So we're going to have in terms of our y value, and we said our terms were x minus 2. The other term was x plus 4. Right? Our x-intercepts, we said, were negative 4, and then we're positive 2. So the question then is, what is going on with our graph in terms of these intervals? Right? So, when x is less than -4, this term, so think of a number like -100, -100 plus 4 is going to be a negative number. Again, if I plug in here, this will be a negative number. And then a negative times a negative is going to give us a positive number. Okay? Now I need a number in between -4 and 2. And so the easiest choice is to think of this being 0. Well, if this is 0, this will be positive. This will be negative, and then positive times a negative is a negative. And then lastly, if x is greater than 2, then everything here will be positive. Right? So I know when x is less than -4, my graph is going to be above the x-axis. Here, we're going to dip below, and then here, we're going to be above. Right? So we have in terms of behavior of our graph. Right? And so we can come up, based on this information, we can come up with an idea of what this graph is going to look like. Right? So we'll do a quick sketch. This is -8, need that number. The other numbers we need are going to be a +2 on this side and a -4 over here. Okay? And then okay? All right. So we know our graph cuts here. We know it cuts here, and we know it touches here. Those points we know. Okay? We also know in terms of our graph that when we're less than -4, we're above the axis, so we know our quadratic is coming down something like this. It goes through here. We know that in terms of it's a quadratic, it's going to be somewhat symmetrical, so we know it's going to come down. It's going to come down, and then it's going to start back up. And then it corrects again at 2, and then it takes off to positive infinity. Right? And so we get in terms of our graph. Right? We can also get in terms of this vertex point. So this point here at the bottom, the vertex point, the x value is given by -b over 2a. And so again, we have that our equation was y equals x squared 2x minus 8. And again, in terms of our general quadratic, which is in the form of ax squared plus bx plus c. Right? And so we know that our b, our a is 1, our b is 2, and our c in this case is -8. So we can get in terms of the x-coordinate of this point. The x-coordinate then is going to be a -2 over 2 times 1. So -2 over 2, which is -1. Okay? So that's the x-coordinate. So this will be -1. And then we can also find out the y-coordinate. Well, we know that x is -1. And so the y-coordinate is going to be -1 squared. 2 times -1 minus 8. So -1 squared, this is going to be 1, minus 2, minus 8, and so this will be negative 9. Okay? So the coordinates of this vertex point will be the point -1, -1. Okay? So So we have in terms of that point, right? So in terms of quadratic or parabolas, okay? So in terms of a parabola, which is a quadratic equation, this is your quadratic. Now, one way of writing them out is in terms of this way: f of x is equal to a x minus h minus x squared plus k. Right? So the vertex is given by the coordinates h, k. So we get in terms of, we can tell the vertex point in that equation. Right? And then a, okay, if a is positive, then the quadratic curve is going to look like this, right? And then if a is negative, then the quadratic curve is going to open down. Right? So a tells you whether it opens up or opens down. Okay? Okay. So in terms of quadratics, so let's first look in terms of our basic quadratic. Y equals x squared. Right? So if I pick some values, I want to know what this graph looks like. So we pick a range of values. Negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. Okay? And so if I graph that quadratic, it is going to look something like our normal quadratic curve, right? Well, what happens if I wanted to look in terms of the slight variation on this one? And let's say we want to now do y equals 10 x squared. Okay, so now I got this 10 in front. What does that do to my graph? Right? So let's do another little chart. Take the same numbers. Okay? And so this will now be 40, and then 10, 0, 10, 40. Okay? And so what this number does, now that this number is greater than 1, it's going to make our graph skinnier. Okay? Like that. Right? So it's going to make our quadratic curve skinnier. Right? When I multiply by a number greater than 1. Right? And then if I do in terms of like this, so now I'm going to multiply by a number less than 1. Right? Again, same numbers. And so now this is going to be 0.4, 0.1, 0, 0.1. And so this is going to have the effect of basically widening out that curve. So we get it in terms of something like that, right? So the number I multiply out in front will have an impact on the curve and what it's going to look like. Right? So then in terms of a quadratic. Right? So let's say we got something like this, y equals 3x squared minus 7x plus 2. Right? First off, we want to know is in terms of our A, our B, and our C. We want to know what A is, we want to know what B is, we want to know what C is. So A is the number in front of the x squared, which is 3. B is the number in front of the x term, which is negative 7. And C is my constant term, which is 2. Okay. So in terms of the vertex of the parabola, the vertex, again we said which is in terms of hk. Well, this equation is not in terms of that other form, but we can still figure out in terms of the h and the k. So the h is given by minus b over 2a. And the k value, can do it either of two ways. It is given by c minus b squared over 4a. Or the other way we could do this is, if we know what the h, we know what this is, we could then plug in and get the other number. Okay? So, for example, here then, we want to know what h is. So h minus b, so this is going to be 7 over 2 times 3. So this is going to be 7 over 6. Okay? So that's the h value. Okay? Okay? So now you want to find the k, the y value. And so the k value then is c, which is 2, minus b squared. So this is going to be negative 7 squared over 4 times 3. Right? And so we do a little math. So this is going to be 2. Negative 7 squared is 49 over 12. And so in order to add or subtract fractions, we need to have a common denominator, which in this case will be 12. And so we can rewrite this as 24/12, and we get a minus 25 over 12. Okay? So my vertex point is going to be the point 7 over 6, negative 25 over 12. Okay? So we know our vertex. So our vertex, I just said, where it's going to be 7 over 6, negative 25 over 12. Right? So we know that this is the h, this is the k. Right? Now the a number is the number in front of my x squared term. Okay? And so that number is 3. We know that. Right? And so if I want to write my equation in this form, so if I want to rewrite this equation in terms of this form, okay, we know the a, and we know the h and the k, and so my equation will be that. And so that would be the equation of that. So given another one. So given one in, so given this one. If I want to know, well, what is the vertex? So I want to know what's the vertex point. Well, the vertex point is going to be minus 3/2 minus 8/3. Okay? And again, it's going to be a minus 3/2 because of the way my equation was defined. Remember, the equation was defined in this way: a x minus 8 quantity squared So in order for this to be a positive number, meant that h itself had to be a negative number, okay? And we know that the a value is -6, which means this should be a parabola that is opening downward. Another example. Let's say we have this, y equals x squared minus 8x plus 3. And we know first in terms of our a, our b, our c. A is going to be 1, b is going to be -8, and c is going to be 3. Right? So my vertex, which is given to be h equals minus b over 2a. And so this is going to be 8 over 2 times 1. And so this is going to be 4. Right? Right? And then my k value, which we said can be done by doing c minus b squared over 4a. Right? But in this case, this came out to be a nice whole number. And so it may actually be just as easy. You can just take this number and plug it in here. Now let's do both ways. But let's first plug in and see what we get. So if I plug this number into here, we get 4 squared minus 8 times 4. So this is going to be 16 minus 32 plus 3. And this will give us a negative 13. Right? And that would be my k value. And if I do it over here, we should find out that we get exactly the same number. And so c is 3 minus -8 squared over 4 times 3 minus -8 squared is going to be 64 over 4. And so this is going to be 3 minus 16, which will be, and we get the same value either way. Right? Okay. And so again, now if I want to rearrange this into the other format, we would get that my equation is going to be f of x. The a value was 1, and so we get x minus 4 minus 13. And so that would be our equation of this. Well, other types. Well, let's say now we have one that was like this. F of x equals x minus 5 times x minus 4 cubed times x minus 9 squared. And I want to know what is the end behavior. Well, really it says to multiply these 3 together. If I multiply these 3 together, this will be an x, this will have an x cubed, this will have an x squared. So x times x cubed times x squared, we would end up with a term that has a highest degree of x to the 6. And so if x goes to infinity, and if x goes to negative infinity, the number in front of all my x terms are positives, so it would be a positive x to the 6. And so this is going to be infinity, and then this would also be infinity when x goes to positive and negative. Right? Okay. And then lastly, you want to do this. You want to write out the equation. Matches the following. Write out the equation that matches the following conditions. So we want the degree of the equation to be 3. We want the x-intercepts to be -5, -2, and positive 7. And we want the y-intercept to be 4. Right? So we're going to write out a third-degree equation, has Paulian intercepts, and we want to come up with the equation that goes with that information. So first off, the equation then is going to be in this form. Y equals A x minus L, x minus M, x minus N, and then just go on and on depending which three we're talking about, right? So this is going to be my L, this is going to be my M, and this is going to be my N. Okay? So I can first start by taking those numbers and putting in, and so we'll have y equals A. X minus a minus 5 will give us x plus 5. And then x minus a minus 2 will give us x plus 2. And then x minus 7. Right? So we got those. Right? Next thing, I know that the y-intercept is 4. Right? Right? So if the y-intercept is 4, right? So if the y-intercept is equal to 4, then that means that the x value will be 0. And so we would have that 4 is going to equal A 0 plus 5 times 0 plus 2 times 0 minus 7. And so this is going to be 5 times 2 times negative 7. So obviously this will be 5, this will be 2, this will be negative 7. And so this will give us a negative 70A. And then the opposite of multiplying is to divide. So divide by negative 70, divide by negative 70. And so A is going to be 4 over negative 70, which can be reduced to negative 2 over 35 from A, right? And so my equation then will be y equals negative 2 over 35 times x plus 5, x plus 2, and then x minus 7. Right? And so that is the equation that goes with that information, and that will conclude instruction.